Don't you want to drill a well?
First, we want to drill a well in the north. Secondly, everyone is against the intensification of sampling in the southern part of the field. This is due to the fact that there is a decrease in pressure along the main reservoir. Let's make water shutoffs there, and we will get a normal liquid rate with low water cut.
Yes, let's do it, but will we spend all the money on this, or will we still drill another well?
Production or injection?
That's the question. If there is an undeveloped area near well 137, which we talked about, then you can even produce there probably.
In order to not delay too long, let's convert 132 to production immediately.
Yes, sure. I also propose to measure the reservoir pressure to see how much we were able to raise it with all our measures on the southern crestal area.
Conversion of 132 to production. Water-gas shutoffs should be done as soon as possible at this well.
I propose to drill one well in this undeveloped area near well 137. If the well produces at a good rate, then, as the next step, we will drill two wells in the north in areas 108 and 109.
For the 132nd well, we shut off reservoir B1, inclusive. We leave B1 in operation. Is that right? Or do we completely shut off B1, leaving only B2?
132nd well, we shoot off to 16-20 meters.
I propose to drill wells in the south to the left of 137. It is necessary to place the well at the highest point on the structure and target the most reserves below.
Geologist, do you want to drill in the northern part of the west?
There should probably be good amount of reserve in the northern part.
I would like to get this information on where the reservoirs are highest. Can you clarify?
What other options are there?
To the left of well 137, or where you mark the reserves, in the area around well 108,
there will be more reserves in the area around well 108. Besides, if we explore them, it will be easier to maintain pressure. There could be two layers with residual reserve.
During this shot, the pressure significantly declined at wells 108 and 109. If we drill another producer, how much pressure will we lose?
Yes. The only thing is that right now they will just stand in the way.
Tim, can I comment? I believe that it's still necessary to work with the primary wells, especially in the north. Look at well 109. The potential there is enormous, as the highest amount of reserves allocated at the primary wells will raise pressure withdrawal from these reserves and will get more cash flow than from a new well.
Can we drill a new well and save $27 million for workovers?
I support the idea proposed by the well testing specialist. We need to drill a well on the northern dome.
The bottom hole pressure at well 109 is now 61 bars. Well 108 has been shut in again due to water cut. Therefore, it is possible to drill a vertical producer below wells 108 and 109. If it turns out to be a good producer, then next year we will convert it to injection and drill a horizontal well on the northern dome, if the budget allows.
I support this decision.
And the remaining $27 million will be used for workovers.
On the southern dome,
we should only work over the most promising oil producers.
shouldn't we pay attention to maintaining reservoir pressure? This means conversions and tracking issues with channeling.
We will have $27 million allocated for all the activities.
Nonetheless, let's check the pressure, how effectively we have raised it through activities so far. What do you say?
We can measure the pressure in well 109 first, if we plan to drill a vertical well around those wells.
Let's measure the reservoir pressure. Can you please state the well numbers?
I have a question to the simulation engineer. I have a previous list of wells. Will we survey them all or selectively? During the second shot, do we have to set the production targets for all wells, or perhaps the information is clear for certain wells?
I believe we shouldn't do it for all wells. We only require at least 2 free wells in each zone to understand pressure behavior. Moreover, if we are talking about the northern part, then we require production history of the entire section. And if we are talking about the southern part, then we must perform it for well where unit B1 is shut off. Because for most of wells, we left unit B1 open. I propose wells number 104, 109, 126, 129, and 137.
Is that all? Do I proceed?
Yes, let's do it.
So, here are the results. There was not enough downtime for wells 129, 137. They are injection wells. The pressure is high.
I believe this is the pressure in the reservoir B1.
Perhaps. Well 126 only operates at reservoir B2, and it is a producer.
In case of well 137, we shut off reservoir B1, and for well 129 too, which may imply that we are injecting too much.
We can see this from the producer 126.
Now we have started to inject a huge volume of water. The question is it worth stimulating this volume in offset wells? We have previously over-injected into unit B11. Now we have removed the injection from there. Let's stimulate it, which is also not a bad thing. But maybe we would shut off the unit B11 altogether. Perhaps we should consider doing it later. The last 3 wells, 126, 129 and 137, are located in south. This is the target unit B2. And in the north, where we have not tackled yet, we have a problem with the formation pressure.
Yes, we need to restore it. That's right.
Can we convert well 108 to injection?
There, it is necessary to work on both well 107 and 108. And, if I am not mistaken, with 103 and E4 as well. For some reason, there is a poor production and injection as well.
If we convert well 108 to injection, it will help maintain the pressure at well 109 and any upcoming new wells.
At the well 108, it is necessary to perform water shutoffs.
Do we have a common agreement regarding drilling locations?
Between the 108 and 109 in a form of a triangle.
I also support this point of view.
If we are going to the further convert it to pressure maintenance, then it probably fine.
At well 108, we probably need to shut off some water or gas zones and convert it to pressure maintenance to allow us to produce more from both well 109 and the new well.
Team Captain, what do you say?
Please repeat it again.
We're going to convert well 108 to pressure maintenance and perform water or gas shutoff on it. We will drill a new producer between wells 108 and 109 below. But first, get enough money, and on the next shot, if there is enough funds left, we will drill formation below the zone proposed by the geologist, and then convert the new well to pressure maintenance.
I think it is a good plan. Aren't we going to do anything with well 107? It hasn't been optimized yet, as far as I remember. We made a reservoir flow profile there.
We are currently discussing drilling.
There will not be enough pressure, so we need to see what to do next with wells 107 and 108. So we will apply remedial jobs to well 107, as we did with well 108.
All right, colleagues. Let's choose a data point. Which coordinates will be more preferable?
Slightly to the left and above where the marker is located.
Okay, geologist, how deep is the well going to be?
Do we need all the reservoir units?
We are developing a new zone, and we assume that in the future, the well will be an injector. So I think it's better to enter all 3 layers into the pay zone.
We need to look at which reservoir zone is active in well 109.
It operates on 3 layers.
Then everything should enter the pay zone.
We can do it for 1680.
This will cost 41 million.
And hydraulic fracturing will cost around 7 millions.
Will we also perform hydraulic fracturing?
Yes, it will have an impact at this field.
Not at this field, but at this zone. But my opinion, it is better to work with the old wells.
Yes, I also have a question. Which information we are going to rely on when drilling there?
Based on a new interpretation of the seismic data which was given to us by the geologist, it is possible to question what he said. So let's look again.
Petrophysicists, please offer your points.
Please open the seismics. The seismic profile shows that the trap is on line 150, and perhaps the trap is extending to overlying and underlying formations. Geologists, regarding the line 109, on what basis will you have a justification?
Geologist, we need your opinion about drilling a new well.
It turns out that the layer should be located higher on the line 150 than it was shown on the map. Accordingly, for the lower layer, the map may be incorrect because there are no profiles in this area. It is absolutely wrong to drill well in the left of 108 to the purpose of exploration.
We don't need to explore, we need to drill a producer.
There are more challenges that there are encounter reserved below well 108 and 109. Perhaps they will be located higher than this map shows. There are 4 risks there.
I didn't get any arguments, but perhaps the geologist is more experienced in this area.
According to the current interpretation, there are reserved below 108 and 109. If we drill there, there should be no risks.
As we are drilling now, we will understand what the saturation is and how the slope is descending in this direction. If everything is successful, we will see a good oil saturation and will be able to proceed further. If the saturation is bad, we will get water in a year, and we will convert the well to injection to restore the reservoir pressure.
I am fully supporting the petrophysicist.
I will support the geologist because I understand that he wants to say regarding the fact that the interpretation of the markings of the structural map are incorrect, and the reservoir unit lies much higher.
How do you know the structural map is wrong? There is no wells here, and you say that here is the flank of the geological structure. Since there is not enough money, I suggest drilling where we know for sure that there is a trap, and not conduct the exploration in order to convert it later to injection. It is true that we will maintain pressure at wells 108 and 109, but in any case do not drill for the purpose of exploration.
Presumably, our interpretation of seismic along line 150 is not correct. Accordingly, the mark to the left of 107 and 108 wells should be higher. There are reserves located below 108, even according to the current maps.
So we have decided on the coordinates.
We have not decided on whether we are drilling or not.
Since we are debating, I would like to ask you, in your opinion, how much oil we will get from there? Obviously, there will be a low permeable layer, even at a maximum hydraulic fracturing value of 100 tons. If we apply remedial jobs to wells 103, 104, 109 and 106, we can increase production even higher.
I really like this approach. Let's go without drilling. And by maintaining pressure, the oil production will be equalized.
On the northern dome, how many wells need workovers? Will the remaining 26 million be enough?
I'm afraid not. We didn't even fix the channeling yet. Currently, we have identified water cut for wells 130, 133 and 134. I believe it was a bad idea to convert well 136. Perhaps we should work with injectors in the north and with producers in the south. And that will be for this shot. We can increase the volume of the water production, but the question is, how much we will profit from this? We'll probably just receive water.
So you want to finish up with the old wells now?
I want us to sort things out with the main wells, solve the issues of shutting off the unit B1 in the south, so we will have a stable production. Only when we receive anhydrous oil and when the water cut drops 2 times from the current positions. Then we can talk about drilling. How remaining reserves are drained. So let's look at drilling. At the same time, we have already configured the pressure maintenance. The next 3 shots should be dedicated purely to drilling.
We still need to estimate how much we'll profit from these activities in order to understand if there are going to be enough funds left for drilling. But I like the strategy to increase reservoir pressure. We seem to have raised the pressure in the B2 formation to normal. Is it possible to slightly reduce the injection in the south and redirect it to the north?
Colleagues, in my opinion, during the presentation there was a conversation that starting from the second shot, we will begin to shut off reservoir B1 and address it only towards the end of development. Have we changed our plans?
I think we will perform even worse in the second shot. Please open the general schedule.
This is not the point. The point is that we don't operate with the existing wells at all.
We have invested 140 million on the main wells. Can you show me the schedule of the first year?
All right, let's work with the main wells.
What else have we missed?
Let's work in the north, because we haven't done anything there yet. Look at the well 103. There is an evident channeling. Will we apply remedial jobs to them?
What are we doing with wells that have auto-hydraulic fracturing? Water shut-offs? Do we completely shut off B1? Or what's the plan?
Yes, let's do it.
The petrophysicist can tell us the intervals for insulation work.
Well 101, from the wellhead up to 1650.
The behind casing circulation at well 101 goes only at the overlaying formation. What about the underlying formations?
Production logging wasn't performed here, but there is for 102. I also propose well 102 from the wellhead down to 1650.
Look, we have reservoir flow profile for well 102. The entire injection goes to aquifer A and C. I suggest shutting off overlying and underlying formations.
Will the price stay the same?
It will be cheaper. 2 water gas shut-offs and 1 round-trip operation. Here, it is clearly necessary to isolate the underlying formation. What do you say?
Yes, everything is correct, and we hope that the auto-hydraulic fracturing will also be eliminated. I asked the petrophysicist to provide me with the relevant depths.
From the wellhead up to 1660 and from 1680 to the bottom hole.
Next is well 103. How are we going to isolate it?
The calculation of the economist showed that shutting reservoir B1 is proven to be effective.
Or we can perform what we did with well 138.
Do you recall what result did we get for it?
We have only shut off B1. It is clear from the pressure history that B1 does not work.
Then we leave B1 too, as is?
Then we will isolate it up to 1602. So only well E4 remains. Here We also need to perform water-gas shutoffs from overlying and underlying formations. I propose to close aquifer A, B1, B3 because there is water saturation and an aquifer C. The well number 107 also needs remedial jobs. The reservoir flow profile was performed during the first shot.
Then here too we shut off overlying and underlying formations as well as reservoir B11.
Then 107 wells from the wellhead up to 1595 and from 1663 to the bottom hole. Do we have any questions about the operation of wells 106, 109?
There is another well, number 108, and there is a reservoir flow profile for it.
Let's try to perform water-gas shutoffs of the aquifer and reservoir B1 so that it operates at production for 1 year, and then we will decide.
At well 109, we have measured the pressure and it was 90 bar. Aren't we going to convert well 108 into injection?
Let's convert it. The main production comes from wells 103, 104, 106, and E4.
Yes, I believe this is the right decision. Moreover, it seems to have insignificant production.
It is possible that there will be a low water cut, but it can be sacrificed at the expense of 4 wells to acquire pressure.
Let's shut off the unit B1 and move on.
Well 108 from the wellhead up to 1595. Next, let's do the conversion.
And we should immediately perform stimulation to well 104.
Well testing specialist, please state the wells that are clogged, but where can we get an oil inflow?
From the producers, well 104 with a wellbore skin of 14.5, 103, 4.3, 130 with a wellbore skin of 17, 132 with a skin of 11, 134 with a skin of 20, and 138 with a skin of 20.
Okay, I am calling the activities. What other areas do we suspect of crossflows?
Let's finish adding the perforation. There is a good pressure there already.
Technically, we have almost finished adding the perforation everywhere we have to. Let's shut off reservoir B1.
According to the pressure of wells 1 to 6, 1 to 9, 1 through 7, it is evident that we inject a lot more than we produce. This means that it is possible to stimulate production.
So, only water shutoffs needs to be done.
We have shut off well 112. Well 113 is not shut off, and well 114 is shut off.
Let's shut off well 113.
So, to clarify, we are shutting off reservoirs B1, we perforate reservoir B2.
At well 114, we did a water shutoff and perforated unit B2.
Well 115, water-gas shutoffs of B1 from the wellhead up to 1640. Well 116, shut off from the well head up to 1645. 117 is complete. 118, water-gas shutoffs of reservoir B1 from the wellhead up to 1635. Well 119, water-gas shutoffs from the wellhead up to 1630. Well 120, there was no water-gas shutoffs. Let's perform it from the wellhead to 1630. Reservoir B2 entered the pay zone. 121, reservoir B2 already entered the pay zone. Reservoir B1 has not been isolated. We need to perform it for the wellhead up to 1635. 122, water-gas shutoffs has already been performed. Reservoir B2 entered the pay zone. 123, water-gas shutoffs has already been performed. Reservoir B2 entered the pay zone. 124, there was no water gas shutoffs. Let's make it from the wellhead up to 1635. 125, Reservoir B2 entered the pay zone. Water gas shutoffs was not performed. Let's perform it from the wellhead up to 1620. 126. We finished adding the perforations. Need to perform water gas shutoffs from 0 up to 1630. 127. We finished adding the perforations. Water gas shutoffs should be performed from 0 up to 1640. 129. Everything was done. 130. B2 entered the pay zone. Water gas shutoffs were not performed. Let's do it from 0 to 1620. 131. B2 entered the pay zone. Let's isolate it from 0 to 1640. 132. Water gas shutoffs of the overlaying formation was done. 133. B2 entered the pay zone. B1 was not shut off. Let's perform water gas shutoffs from 0 to 1640. Well 134. B2 was not shut off. B1 was shut off. 135. B2 was shut off. B1 was not shut off. 136. I suggest leaving it as it is. 137. Everything is done. 138. Everything is done. So in total, 14 water gas shutoffs. Each water gas shutoff costs 3 million. We now have 20 million. Can we make 6 units in this shot? We need to put them in order of priority.
Let's just do the producers and leave the injectors for now.
Then we perform it on wells 120, 125, 126, 127, 130, and 133. Can you state the intervals?
Well 120 from the wellhead up to 1635, 125 up to 1620, 126 up to 1630, 127 up to 1640, 130 up to 1630, 133 up to 1640.
Let's make a call.
So as I understand, we have put our main focus on reservoir B2.
That's right.
There are several more wells that are injecting into B1.
All right, I am making a call. We have a bit of money left, which we can spend on logging reservoir pressure. Or we can perform reservoir flow profile at the injector so that we can perform water gas shutoffs during the third shot.
Can we apply stimulation or perforation?
There's not enough money left for stimulation.
And we have finished adding the perforations wherever possible regarding reservoir B3 in the north. Should we do that?
I suggest well 104, or perhaps well 103, or 106. Can you suggest which one is the most promising?
I'm voting for 106.
There's a large water cut at 103, which may be shut off at the next shot. Wells 104 and 106 are both good candidates. That's why well 103 is better.
Okay, please provide me with the intervals.
And since 103 was isolated, maybe there is no sense to do it now. When the water cut falls, then we can use another one. Where is the highest reservoir thickness?
I do not vouch for the interpretation of open hole data. How are we certain that in the interval of 106 it is oil and not water?
It is definitely oil. You see, the water would have a much lower resistivity.
Still, let's perforate one well after all, and that will be it.
The depths are from 1644 to 1648. Done.
Next, the production targets.
Since we have almost shut-off reservoir B1 everywhere, the minimum downhole pressure is 45 bars.
I'm in favor for leaving 101 and 102 at the same production targets.
I support them, because they will now target the injection into the reservoir.
Let's increase the value of well 107 to 200, or we can let it be.
And there are no more risks of the channeling there. You can put 200.
We have converted well 108, so you can put 200 there. 112, 140 is possible. 113, 200. 114, 200. 117, 200. Let's leave 122, 200. 123, 300, let's leave. 124, 270. 129, 150. 131, 200. 135, 310. 136, 320. 137, 100. E3, 200. 103, 100. 104, 140. 106, 90. 109, 65. 110, 110. 111, 125. 115, 140. 116, 140. 118, 160. 119, 110. 120, 80. 121, 170. 125, 80. 126, 85. 127, 120. 130, 80. 132, 90. 133, 75. 134, 170. 138, 180. E4, 50.
All right, let's place the shot.
Let's analyze the results of the second shot. We now have $2.169 million, which is good. And regarding the oil, if we backtrack according to the analysis of the shot, we reached the peak indicators that the previous development team was able to achieve. We even surpassed them in terms of liquids. We are also doing very well in terms of injection. And what is very important, our scenario to close the water cut hypermeable sublayer gave fruitful results. And we were able to significantly reduce the water cut.
Yes, that is. The average water cut has already decreased from 80% to 60%.
Yes, this is very good. I think that it is possible to see the results for each well. Regarding well 101, the remedial jobs were applied after the auto-hydraulic fracturing. I think that we can add a little more here. What do you say? Or should we be concerned about breakthroughs?
Let's wait and see. For now, the well 103 has been shut in. Technically, on the one hand, the well is located inside the dome. And on the other hand, it is unclear how wells 101 and 102 operate. Based on proposals, it is possible to convert this well to injection. That is, to conduct a production logging and then convert it to injection and try to build around this well, taking it as a reference in order to increase production at wells 104 and 106.
That is, it is a potential candidate to be converted into an injector.
This is one of the options.
I suggest that we first consider all the wells. Just looking ahead, I will say that the well E4 was also flooded.
I believe we do not apply remedial jobs to them.
As I believe, there were remedial jobs applied to well 103.
There were workovers on wells E4 and 103.
So it didn't work out. Well 104, by the way, turned out great.
There is not enough pressure here. Technically, we reach the maximum potential, but due to the fact there is no enough pressure, we have a drawdown.
Alright, I agree. Let's convert well 103.
Here we see that well 106 also seems to be working to the maximum potential. The pressure is reduced to a minimum.
You believe well 103 will be able to assist it?
The well E4 might just do that.
Well 107 seems to have a good injection, just like well 108. Can we optimize the production targets for injectors? Or is it enough?
I don't think it is necessary. The same goes for the well 109. There is not enough pressure there, but there are plenty of reserves there.
Perhaps we can increase on well 108 just a bit.
There is not enough pressure.
Regarding the current situation, we need to create additional injection data points. If we just increase the production target at one well, we can face a breakthrough.
So we have to drill.
Apparently we need to drill an injector.
The well E4 should be converted.
What is the production rate for it?
Let's wait and see.
Well 110 didn't have any reaction, and it is located here in the appendix. That's why it produces so little. The water cut is high.
This is a different situation. There was a water cut at wells 103 and 104. However, the pressure went over to wells 110 and 111.
They are connected through a layer, right?
I see a connection based on the increasing downhole pressure, although we do not have a water flood in the area around wells 110 and 111.
This may be due to a water cut.
So this is the water from the same well.
Because when the water quantity rises, the amount of water flow increases, along with the mobility in the general system.
The water cut increased slightly. I do understand this situation when the water cut was, figuratively speaking, about 0 and then it became 80. And here we have a relatively insignificant increase from where it was initially.
In other words, there was a slight increase in bottom hole pressure.
Well, yes. Show me real examples of wells where you could observe such a situation, such that 10% increase water cut would increase the downhole pressure by 20 bar.
So it's definitely not channeling, right?
That's right. Let's proceed further.
112 was converted to the pressure maintenance. It seems to be working at the maximum potential. Is it possible to reduce a little? What do you think?
Yes, it does.
Are you referring to well 113?
The situation is normal here.
The same goes for well 114. And regarding well 112, we can reduce the flow rate. And there is a small growth at well 115.
We have not shut off the upper subunit there. This is why we had water cut.
Let's shut it off and perform water shutoff on B1. The same goes for well 116. So after all, our strategy that involves shutting off reservoir B1 was correct.
Now we will go through all wells that have been shut off, and we will be able to see better. Well 117 seems to be operating fine, but we can increase it. Apparently, the injection of the well is off target.
It is possible that reservoir B1 is operating, or there is a possible channeling, because the bottom hole pressure is too low. If it was indeed operating at B2, the pressure would be around 200.
We have isolated reservoir B1. Let's proceed.
It feels like this production is natural for this well. So when we reduce the injection volume, the bottom hole pressure dropped. If we leave an extra 100 cubic meters of injection, we can use them when well 117 declines even further.
We need to order production logging.
Yes, as there was no effect from water gas shutoffs.
Production logging at well 117. Well 118 is operating at maximum potential. Is the pressure insufficient?
And we haven't shut it off either.
There was no time for well 118, but nevertheless it provided a good increase. The same situation for well 119 and 120.
Look, we have shut it off, The water cut has fallen to zero. Now we have 40 cubic meters of pure oil.
Is it necessary to increase the pressure at B2? There is also not enough pressure at well 121. As a matter of fact, there is not enough pressure in this entire area. Well 124 has a good injection. 125 there is not enough pressure, but it's still good.
The water cut is zero. 70 cubic meters of pure oil.
The same situation for well 126.
We can increase it slightly at well 126.
The water cut has already started. Where is it coming from?
When injecting, the water begins to reach producers.
At well 127 we have reduced the water cut. The pressure is just a bit from being enough. And should we reduce it a bit at well 129?
Yes, it does.
Well 130 there is not enough pressure, but we can optimize it.
And we have closed off, but at the same time, the inflow has been minimized. It's likely that wells 135 and 136 have an influence here. It appears that these wells draw a huge volume of water there. But this is another topic.
Well 131 operates fine. It also helps to raise the pressure.
132. Here we can further optimize.
The pressure drops here.
The pressure dropped because it was injecting. It was routine for a year, and then we started it up at a small pressure. That is not so large production target. We can still at least optimize up to 45.
So you think the pressure maintenance is effective?
I believe so, especially since water is still coming. I don't recall if we shut off the first unit.
Yes, we have performed water shutoffs here. The pressure at the well 133 I think is optimal, but you can still increase it. There is no drop in the flow rate due to pressure decline, and the correct production target is selected. The flow rate of well 134 has been reduced from 170 to 50.
Yes, we have restricted it.
We have also performed bottom hole treatment.
We have applied bottom hole treatment and performed water shutoffs to overlying formation.
It is necessary to perform production logging. The bottom hole pressure is oddly high.
B1 is working there. Perhaps it is an inflow from overlaying formation.
We have increased the liquid rate there by 5 times.
Yes, because there was an optimization.
It's just possible that we encountered water cut. If we perform production logging, everything will be clear. This well is still working and was not yet killed. We will correct the situation.
We are going to lower a little at 135.
I think so, yes. At least up to 250 cubic meters per day.
Then maybe there will be no breakthroughs. At well 136 we reduced it a little bit, and for well 137 too.
It seems to me that we can leave it as it is. We have already reduced it, and it operates normally. The pressure is not at the limit. The injectivity is good.
I think that we inject too much. How efficient is this well? What about the reservoir properties of the well?
If we picked up the entire unit B2, then the thickness there is 12 meters. The permeability is 30 mD. According to the analytical model, the value should be 90 mD.
Why is the water injection rate of this well so small? Do you think there are no wellbore skin here?
The permeability is low and unit B2 is in operation.
Of course, we reduce the injection.
Maybe we should perform hydraulic fracturing?
I don't think that it's necessary. We can make an auto hydraulic fracturing by increasing it to 150.
Can you explain why we need to perform auto hydraulic fracturing?
Auto hydraulic fracturing will not happen here. The well withstood the maximum pressure that we created. The well is in operation. No hydraulic fracturing is needed. Current production target is more than enough.
The well 138 has a good increase. It is operating at the limit. However, the pressure is insufficient.
Yes, but we can, however, shut off the first unit here.
It's fine, your idea worked.
Technically, the acid simulation was successful. Not to say that it is 100% effective, but it works. The well is located on the flank. If required, B1 can be shut off altogether. Let's leave it as it is.
But how much reserve volume will we lose? If there was a high water cut, it would make sense to shut it off. But there is only 60%. I think we will make it to shot 5.
No problem. We just produce a lot of water. I am in favor of not extracting excess water.
And what do you think about drilling an injector in the south? Does it make sense?
Let's finish reviewing first.
E3, we reduce it a little. E4, like the well 103, water cut has decreased.
It seems to me that at both wells 103 and E4, it is necessary to make a reservoir flow profile, and then determine which one should be converted to production, and which one is injection.
We require production logging for the well E4. According to the activity list, 5 wells were identified for production logging. Those are wells 117, E3, E4, 134, 103. Let's start with them and review our further strategy based on the results.
Before we start doing anything, we have 125 million at our disposal. What is our plan? Drilling 2 producer wells, 1 vertical injector, and 1 horizontal producer.
Based on the result, let's focus on pressure maintenance. Overall, we have acquired good results even without drilling the producers. So if we going to drill, it is going to be injectors that will increase the reservoir pressure.
We will now convert wells 103 and E4.
I believe that it will be enough to just convert these wells. My suggestion is that we drill 1 vertical producer and spend all the remaining funds on the primary wells. Reservoir flow profile, water gas shutoffs, convert to pressure maintenance.
Let's convert 2 vertical wells into production in the north around well 108. The other is in the area around wells 136, 137, and we spent the rest on workovers.
Let's start with the southern undeveloped area. I would like geologists and petrophysicists to join the discussion and provide data points and relative depths.
According to the structure map, it is necessary to identify where the highest point is.
On the screen, there is a structural map of the B1 formation top. The formation top is located at 1,640 meters. According to the reservoir B2, 1,680 meters. According to reservoir B3, 1,700 meters.
Let's also take a look at the seismic data.
According to the seismic profile of well 243, the formation top of the reservoir B3 is located at 1,690 meters. It is necessary to drill with a headroom of about 1,710.
There was water in reservoir B3. There is no point to drill so deep.
Okay, what about reservoir B2?
At B2, it is also quite low.
We need to mark it somehow.
Probably we will drill up to 1690 meters.
Yes, you can even make it lower.
Let's drill then. The coordinates are 54, 90.
Geologists, do you approve?
Yes, I approve.
And believe that if these sublayers are up to standard, we can achieve higher reservoir coverage through hydraulic fracturing. We are beginning to drill now. Let's now look through the results of the open hole data.
We are a little short from reaching reservoir B2, but it's still identified to be water-bearing. The barrier is rather small.
I propose to perform wireline formation testing both on the aquifer and target reservoirs. After that, we have to make hydraulic fracturing on the bottom part of the target zone in order to cover this zone and produce at low differential pressure data points 1620 and 1646.
Layer A has a very high pressure.
Surprisingly high, even higher hydrostatic pressure. At the reservoir B1, it is slightly higher than expected level.
Technologist, please bear in mind that the pressure there is 20 bar higher.
I propose to make perforations 1636, 1651 meters. What will the petrophysicists say about this?
I propose 1636 to 1652, but the barrier of 4 meters is rather small. Can we reperforate just reservoir B1 too?
This zone has not been developed. There are still reserves in reservoir B1, so I propose to make a hydraulic fracturing at B1 and let the well produce at low differential pressure. We just want to assist reservoir B1 in operating together with B1.
The pressure at layer A is 20 bar higher, therefore channeling is most likely to occur.
Maybe we will perform hydraulic fracturing on the formation at 1650 meters.
The overlaying formation has a pressure of 171 bar and 3 meter barrier. I asked the technologist to calculate the minimum downhole pressure that will allow us to avoid the channeling.
So we know the injection, bottom hole pressure and reservoir pressure. What will be the resulting flow rate? This is a question to simulation engineer.
I propose to step back from the barrier. Let's not make it 3 meter, but rather 5 or 6. Then we can create a big drawdown.
Another solution is inject to 1643 to 1652 meters. Perform hydraulic fracturing. Make B1 enter pay zone and then produce at these conditions, and we have a better chance of channeling not occurring. Then we make a perforation and hydraulic fracturing at data point 1646. We are putting the well into operation. We are drilling the second well. I ask a geologist to join the discussion and state the coordinates and depths in the northern section.
Below well 108 and 109, in the green zone, the coordinates are 31 and 36.
Can you open the open-hole log data for wells 108 and 109? Are we going to inject into reservoir B3?
We can. The depth is 1670. We can make some headroom and make it 60-80.
Okay, let's wait for the calculations to finish.
Are we going to perform reservoir formation testing?
Yes, we should perform it.
Open hole data of the new well. I would like to ask petrophysicist to evaluate the results.
Reservoir B1 is clogged and has poor reservoir properties.
What are your recommendations regarding perforations?
1620. Hydraulic fracturing.
We must first perform hydrodynamic logging. 1580, 1593, 1604, 1620, 1650.
The well did not reach 60-80. The last layer is not B3, but rather an aquifer.
Then which layer is which?
1636 is B3 with B2 together.
All reservoirs have reduced pressure.
Now let's perform the perforation. The previous values were 1598, 1604. Petrophysicist, please tell me the values for B2. Is it 1616, 1630?
Yes, that's right.
That's it. We entered the values.
Will we perform hydraulic fracturing?
Yes, at a depth of 1624.
Then, I suggest that we still perform a reservoir flow profile and see what inflow are we going to get.
Yes, let's do it. The reservoir flow profile was not informative, we just looked at the cross flows and the pressure difference. I suggest we perform reservoir flow profile at all wells that are currently in operation.
We have performed reservoir flow profile, and now we know the inflow of reservoir B2. The well is in operation. When we will get the total inflow, we will understand what is happening with B1.
Look, since we have a low formation pressure in A, the shale break is 4 meters. We can safely lower the bottom hole pressure to 45 bath.
We have $503,000 left and 7 activities related to shutting off reservoir B1 in the south and planned activities in the north, E3, E4. I would like to ask the economists to join the discussion. There are 2 scenarios. 1. Finish operating with the southern block, shut off B1, all wells. 2. Some of the activities should be done in the northern block, but if we focus on them, will they provide the same increase? But here it is already clear that the increase will be 2 times less. Does everyone agree?
Yes.
E4 is converted to injection.
There are enough target injection. Let's work with the producers now.
Water shutoffs 115 from the wellhead to 1640, 116 up to 1645, 118 up to 1635, 119 up to 1630, 121 up to 1635, 124 until 1635.
So, do we approve this activity pool?
Yes, let's do it.
Now, let's concentrate on the reservoir pressure.
Yes, this is important when setting the production targets. Simulation engineer, please tell me which wells are most important.
It's necessary to investigate the reservoir pressure at wells 106, 126, 132, 134, E3, 129, 123, 114, 113, 101, 102, 110, 111, 137, and 138.
Yes, correct. Let's see the production targets.
Please state the well number.
Well 101.
200s.
Well 102.
50.
Well 107.
200s.
Well 108.
400s.
Well 112.
125.
Well 113.
230.
Well 114.
90.
Well 117.
160.
Well 122.
220.
Well 123.
190.
Well 124.
130.
Well 129.
190.
Well 131.
It is currently 600, but I suggest limiting it to 400.
Well 135.
400.
Well 136.
It is currently 500. Again, let's limit it to 400.
Well 137.
140.
Well E3.
80.
Well E4.
280.
We have an excess of 245 cubic meters. I suggest to remove from high rate wells.
Yes, at well 131, let's leave 300. And at well 108, 300.
At well 135, it is going to be 380. And at well 136, 375. That's it. Now the producer wells. 103.
You can put 20.
Well 104.
Let's leave 140 for now.
Well 106.
The calculated value is very small. How much did we have there?
90.
Okay, let's leave 90.
Well, 109.
80.
Well, 110.
90.
Well, 111.
120.
Well, 115.
70.
Well, 116.
74.
Well, 118.
60.
Well, 119.
60.
Well, 120.
50.
Well, 121.
65.
Well, 125.
80.
Well, 126.
And also 80.
Let's leave it as it was, 85. Well, 127.
120.
Well, 130.
70.
Well, 132.
60.
Well, 133.
75.
Well, 134.
200.
Well, 138.
200.
Well, S1.
105.
Well, S2.
175.
So, we all agree on the wells.
Yes, let's place the shot.